calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hello?
Let's try that again. Let me back up first.
So quiet.
Hi, Tara. How are you?
Hi, Mark. How are you? Hi, everyone.
Yeah. Hey,
Oh, my goodness.
we got some fun planned for you tonight, and actually some other time. Tara and I were working it out before, but you're not going to see that tonight. That part, the really fun stuff, we'll do at the next show. But I wanted to say hi to everybody out there listening. It is I, Mark D'Antonio, of course, and that's Tara DeUlis, who is one of the members of the Sky Tour Livestream family. She's one of the 3 people in our nonprofit corporation, and look at her. I mean, just look at her sitting there. I mean, she knows what she's doing. She's a brilliant artist, and
Ah,
oh, you are. I mean, she made our door for the Sonoran telescope. There it is.
hey, there it is.
Don't look at that guy in the white legs. Okay,
Nothing to see there.
but that's the door she made. It's entirely made of bottle caps
Yeah.
of different colors, no color added, actually. And the sun bleaches things. So now that was when we first put it in, but now the door is bleached, so it's almost colorless, and it's actually kind of interesting in its own right,
Yeah.
looking this way. Very, very cool.
Just
When
subtle
we
colors, kind of
Yeah,
monotone. So
yeah, and when we first started the Sky Tour journey, it started with this. It was just a single flag in the desert dirt out southwest of Wickenburg in the Sonoran Desert. That's what it was. And then it became this concrete pad, which by the time it was poured during the day, by evening, I was standing on it taking photographs with a camera on a tripod. And that was cool as well. And I'm telling you, the beautiful night sky, the Milky Way, it just went right to your chest viscerally. It's like, wow, unbelievably beautiful. And
it's
then
gorgeous.
thanks to Tara, this telescope and Marianne,
Yeah.
this telescope was installed. The dew shield on the front here is removed. That's why you see that black thing sticking out of the front and the camera. Okay, yes, the camera's on the front, really odd. And so we ended up making an incredible journey come true. And here's
Yay.
Tara working on the telescope. And she did a lot of the work without me being there because I was in Connecticut where I live. And she's just like an hour. Is it an hour?
It's about an hour and 25 minutes if you're pedals to the metal.
Holy cow.
Of course, at the speed limit, of course.
That's the speed limit, of course. Wink, wink. Yeah. Yeah. So that's pretty cool. And so we ended up doing a lot of really neat things out there. Here's Tara looking at the telescope. That has the dew shield on now. You can see that extra blue extension to it. And this is telescope number 1. And we never really knew how far this could go until we found that another site over 200 miles away in Arizona was another good site for another remote telescope. Now, this telescope that you see Tara looking at right here, I run that from here in Connecticut.
Yeah.
So I take the roof off, it's a roll-off roof observatory, and the sky is open to it. And I turn on the telescope and run it. I wrote a program to access the power of the telescope and so forth. Learned an awful lot about that side of things and doing robotic attachments to the telescope and stuff. And so once we got that one done, I guess the idea was maybe we can do more. And so that's just what we did. And so the first thing to understand is that down in Benson, there's this observatory. Here it is. That's a big dome up on the hill. That's the Vega Bray Observatory. That's what it was. It used to be a bed and breakfast. Now, the original owner died, and the new owner took it over. Doesn't have the bed and breakfast there anymore, but where they used to have the bed and breakfast stuff going on, they've turned that into another big roll-off roof observatory that's 30 feet square.
Wow,
Okay.
awesome.
And it has many telescopes in there that are all pointing at the same exact spot in the sky. Now, for those of you listening, why would you look at the same spot in the sky? What's the thing or the reason why looking at the same spot in the sky would be important? Okay, who knows the answer to that? I'll let you think about that. Put the
Okay.
answers in the chat and I'll see it. Okay.
That's a hard one. Well, there's a lot of guesses, I guess.
Yeah, but there's only one correct answer, believe it or not.
Awesome.
Why would you look at the single spot in the sky? You know?
Mhm.
All right. For the world is hollow and I've touched the sky. Hello. Yes. Yeah. So I can give the answer instead of making people think. They don't want to come here to think. Um, yeah, so that answer is that uh, when you look at one spot in the sky, it means
Mhm,
looking at a particular thing that doesn't move. Donald Kunzer says looking for nova. That's a good thought if you're looking at
mhm.
things. However, you'd be tracking the sky, Donald. You'd be tracking objects in the sky that look at like a galaxy or something. If you're looking at one spot in the sky, the telescope's not tracking anything. It's just sitting on a tripod and looking at a spot in the sky. So, what types of things are just sitting there in one spot in the sky? Well, the answer is very simple. Although it's
It
simple
is?
when you know the answer, it's very simple. Geostationary satellites.
Oh, I
Those
was thinking deeper space. Okay.
Oh, okay. Yeah, no, these are things, for instance, these are satellites
Oh,
that are sitting over one spot on the Earth and they rotate around the Earth at the same speed that the Earth is rotating
cool.
as from their
Mhm.
perspective. So they always see the same position on the Earth. They're always looking at the same exact view for the remainder of their existence. Kind of boring.
So they're looking at the Earth,
They're looking at the Earth and
and these are looking at it.
that's right. Because when you look at a geostationary satellite, okay, a geostationary satellite and a geosynchronous satellite are actually the same term that's bandied about for both things, but they're actually slightly different. Geostationary means that they're staying over one spot on the Earth, but they have a strange orbit that they go through. Okay,
Hmm.
geostationary satellites are right in the same spot. Okay, but they're still, the generic definition of they hover over the same spot of the Earth because they're rotating at the same rate as the Earth, going around the Earth at the same rate, is true for both. So it's a subtle distinction. Okay. However, I will say this: when we talk about looking at, let me just do something here. When they talk about um, observatories like this one, okay, this telescope that was in the Silver Dome was a big telescope at one time. And exactly, Donald. Yeah. So that telescope is no longer being used. And so now what happens is they have different types of telescopes on the mountain. And those are these guys. These are 10 block buildings. Okay. And each of them is a roll off roof observatory. So if you look at the one nearest to us, it has a 2 above the door handle. Okay. Then there's a 1, then there's a 0. So we're looking at building number 2. So that's, 2 into the line. All right. Well, that roof rolls off to the left side and out of view. Okay, opening up the entire interior. Now that's a 7-foot roof. So when you put your telescope in there, you mount it higher so it can look over the top of the walls. All right. And that's what we did. And so this allows us, in fact, here's building 0. This is ours. And what we did was we changed the door. So that door is now a solid white door. The previous door was hard to open, didn't open well, and it opened
Mhm.
inward. Now,
Oh,
if it,
that's tough.
it is because
Yes.
that
Mhm.
limits where you can put stuff inside.
Right.
So you walk in on this door and you would have hit the telescope. Okay. Well, we made this door, we had the door changed to open outward. So by opening outward, now when we go in, we have the full interior, which is 10 by 10 or 11 by 11. I can't remember. I think it's 10 by 10. The full interior in order to take advantage of. So that gives us the ability to put our telescope in there and have room to spare. Here's an example. This is the telescope that we put in. This is an
Nice.
11-inch Celestron telescope. Okay. The telescope you can see right up there. Okay. And it has a shield on the end. The cameras are at the back on this telescope, not at the front. This is not a wide field telescope, which is what you get. You get a wide field when you have a camera on the front end and use this particular lens that we get from Star Arizona. Amazing folks down there in Tucson.
Hmm.
Okay. And you've been there several times, Tara.
Yep.
Courtesy
Fun
of
place to be.
it's a fun place. They've moved
Mhm.
and they've got a bigger facility and a
Oh,
lot more
cool.
capability. So it's really fantastic. And that white mount you see just to the right of my head, that's actually the telescope mount for this particular telescope. And we have a second one. And if we ever have to move out of the Wickenburg location, we're going to put that telescope on one of these mounts because this mount
Awesome.
is extremely reliable, far more so than the existing mount that came with the other telescope. There's a few hurdles after that, but other than that, we're good. And so this particular location allows us to photograph things just beautifully. I mean, we can see, like, for instance, this telescope photographed this. Now, what is that?
Oh, pretty. I know what that is. That's the Orion Nebula.
That is correct. And you would know that from having
Hmm.
done the door.
That's
That's
right.
actually the bottom of the Orion Nebula. Okay.
Mm,
The Orion Nebula heads off the top of this image. Okay. And that at the bottom has its own name. That's called Messier 43
mm.
or Demorane's Nebula. And that is, if you look very carefully, look at all the detail in the brown dust in there. Okay. So we're seeing the orange, the reddish orange of
Right.
hydrogen alpha, ionized hydrogen. And then you see brown stuff everywhere. That brown stuff is dust that was created by countless supernovae and countless red
Wow.
supergiant stars, just littering the cosmos with their interior when they went supernova, and also sloughing off these molecules of dust from the outer reaches of these gigantic stars.
And that's all in front of the nebula, correct? Versus the light
Yes,
behind it.
very,
Yeah.
very good observation.
Right.
That dust is in the foreground. So when we look at
Yeah.
that dust, we're looking at dust that is actually, up here, and the nebula's back here,
Right.
and we're
Okay.
seeing it behind it. Yeah. And that's what's really cool. And we've taken other pictures, like here's a supernova remnant we took the other night. This is called the Crab Nebula. Now,
Ooh.
in 1054 AD, Chinese astronomers saw a new star appear in the sky, and they didn't know what it was. They couldn't possibly have known. All
Mm-mm.
right. So in later years, at the same position that these very accurate astronomers had calculated for the location, we found this. It was an expanding supernova remnant. Now, this is a site where there's what's called a pulsar. At the very center of this, you can actually see the star. It's just to the upper right of center there, and it
Hmm.
looks, it's the brightest dot just in a little bit of the whitest part of the nebula.
Right.
Okay. And it's just to the upper right of that center part of it. That is the Crab pulsar. And it's a star that has two hot spots on it that are giving off light. And the star is rapidly rotating. And the star itself is the size of Manhattan Island.
Wow.
It's called a neutron star.
That's tiny.
It is. It's like 25 miles across. And when it rotates, there are these little hot spots on it, like lighthouse beacons that flash us every time the star rotates. And what we see is a rotation rate of this Manhattan sized star of 33 times per second.
Mm.
Okay. Can you imagine something the size of Manhattan rotating 33 times per second?
How could you even count that?
I know, right? You have to
Mhm.
you have to take some high res or high res video and do it at a very, very high frame rate so you can actually slow
Mhm.
it down to actually watch it. And there is video of this going and they put sound in so you could see when it's doing it at about that frequency. But that's not the fastest neutron star rotation. Neutron stars that are pulsars rapidly rotate, and 33 times per second is respectable, but is by no means a record. The record is held by another star that goes over 700
Oh my
times per
gosh.
second.
It has to be smaller, right?
It is not.
Hmm.
It is the size of Manhattan Island. Now, why in the
As
world?
well. Hmm.
How can it hold together? Shouldn't
Yeah.
it fly apart? And the answer is at a certain speed of rotation, everything will fly apart. So, how does it stay together? Well, the answer has to do with its immense gravity and its immense mass in such a compact amount of space. It was a much larger star
Hmm.
that collapsed into this neutron star. So, you got this massive amount of mass inside this 26 or so mile diameter star. So, it can spin very rapidly and gravity can still hold it together.
Wow.
Odd, isn't it?
Glue. It's space
It's like
glue.
it's space glue, exactly. You know, uh, and so when we look at the night sky, we also look at things like this: Betelgeuse. Okay, that's the upper left star in Orion. Now, what's interesting about Betelgeuse is Betelgeuse used to be a bright blue star. That used to be a hot blue star. And the thing about Betelgeuse is that it used to live at the right here at the upper left side
Hmm.
of this diagram. This is the Hertzsprung-Russell diagram. You measure across the side here. You can see we're measuring luminosity or brightness, and across the bottom down there, it's the color, which relates to temperature. Okay, hottest and bluest are 30,000 Kelvin. It's a temperature scale and above, and coolest are about 3,000 and just a little bit less Kelvin. And you notice that snaky line, those are all the normal
Yep.
stars that are fusing hydrogen into helium. Those are normal. Well, Betelgeuse used to be up there at the top. It used to be a hot blue star. So wait, why is it at the upper right of the diagram now, as it shows in the diagram? It even reads there, it says Betelgeuse. Well, what happens is when a star uses up all of its hydrogen, one of the things that happens to a star is that the core begins to collapse a little. And when it collapses, a lot more radiation is coming out and it pushes those outer layers out like an inflating balloon. And so the layers get further and further and further away from the exceedingly hot core of the
Right.
star. And when that happens, they cool off. And in the universe, red is cooler and blue is hotter. So as they get farther and farther away from the hot source, they cool off. So the star was blue, then it went to white at some point in its history, then it went to a yellowish, then it went to an orangey, and then it went to a red, which it is now,
Wow.
as it expanded in size. Now that all happened over just a few thousand years when it went to the red giant stage, the super giant stage. So that said, Betelgeuse is literally in the last throes of its life. Betelgeuse will eventually go supernova. And so when he asked for an update on Betelgeuse, it hasn't gone off yet. I can't wait for it to go off, and I hope it
Yep.
does when we can see it. Because remember, as the Earth goes around the sun, the stars behind the sun could eventually be and will eventually be in there. They're almost now the stars of Orion and eastward. As we go around the sun, the stars of
Yeah.
Orion are going to go, behind the sun a bit. And so if Betelgeuse goes off when it's in our daytime sky, it's still going to be exciting. You know why? Because we're going to see
Yeah.
the star in our daytime sky.
Wow.
And we only see the sun in our daytime sky. But if Betelgeuse goes off in the daytime, you're going to see a new star in the daytime. You can't imagine how many photos of that's going to be taken.
Oh, can you imagine? Oh.
Oh, yeah. Yeah. Now, if it goes off before Betelgeuse or before Orion goes fully behind the sun, or too close to the sun to see it, people will wait till just about sunset and they'll take some pictures of it. There it is. And then if it goes off while it's in the daytime sky, after it emerges from the other side of the sun, then that'll be in the early morning, like at the dawn hours or whatever. And you'll see Betelgeuse rising as a bright second star in our
Oh,
sky.
cool.
It's going to be very bright.
For about
brighter
like
than
3 weeks, right?
actually for novas, yeah, maybe okay, but for supernova, it could be
Mm.
several months.
Oh,
So for several months, we might actually see Betelgeuse in the sky. And I think that'd be
wow.
pretty cool. Don't you?
Mhm.
Oh,
Oh,
yeah,
God,
it'd
I
be
would
pretty.
love to see that. Yes,
Yeah, because
absolutely.
it's once in a lifetime. You certainly don't get to see that. Now, in Sky Tour Livestream, I've shown people supernovae that occur in other galaxies. We have tracked them, we watched
Right,
them, we gauge their color. But this would be very different than that because this would be a daytime sighting, and it'd be very obvious. We're not talking about something that would be hard to look for, but it's kind of there. No, no, you won't miss it. You can't miss it. But it's far enough away that Betelgeuse, when it goes supernova, will not hurt us. Okay. You'll
right.
just see the light coming from it. You won't see any of the deadly radiation from it. That's going to be local to where Betelgeuse is, 750 light years distant from us. You know? Hey, thank you, Genghis. So, anyway, so that's interesting. So, what I wanted to do tonight was to take us down another path. And I'll breeze through this first part a little bit because we want to talk about some of the other things at the other end, which Tara asked for specifically, and I want to indulge her because she's worth it. You know, she's a good
Everybody
student.
will love it, I'm
I think
sure.
so. I think so.
Mhm.
But let me start by adding this up here. Okay.
Hey.
Yeah, we're still here. Hi. You know. So the talk is called Entering into Science. Now, alternative name is Mysteries in Astronomy. Basically the things we don't understand. And I just wanted to show some of this to you so we can get a feel for what science knows and what science doesn't know. And it's actually
Okay.
kind of cool, right?
Yeah.
You ready for this? You want to go for this?
I'm ready. Go,
All
go.
right.
Yay.
Okay. And but then I want to ask. No, I'm just kidding. All right. All right. So yeah. So let's go check out now. Science, as I've said to many people over the years, serves us well. However, it doesn't always serve us well. There's certain things we don't know, and those are the things that we want to talk about. So let's talk about some of the
Okay.
unexplained phenomena. This is part one of this talk. Um, there, there's a lot of things we do understand, and when the Chandra X-ray satellite was trying to look in the direction of Messier 87, which is a large elliptical galaxy in the constellation Virgo, it saw this really interesting set of shapes here. Okay, these
Yeah.
shapes that we're looking at right here. This is a source, and then you see this jet moving out. That's
Mm.
very interesting. That's an X-ray jet. It's very it's actually relativistic jet stuff moving near the speed of light, and
Wow.
it's moving away from the center of this galaxy. Really quite impressive. So that's interesting stuff. But then the question
Awesome.
is, okay, and that starts kind of a path toward what is that. So using other techniques, we actually were looking at this object and determined that it was a supermassive black hole.
Ah,
Okay, in the center of the
cool.
galaxy, Messier 87, right here. Okay, something like 44 million light years away. So we're seeing it as it was 44 million years ago, which is kind of interesting.
Wow.
The universe is a
Mhm.
time machine, right, Tara? You know this.
Yep, I bet it's changed a bit since then.
And it's right. It probably has. you know um so to see this better, we use this global network of radio telescopes that all talk to each other, and as the earth rotates they all take pictures of this,
Okay.
and they were able to put the data together. And when they put this data together, this is what they saw. This is the highest resolution image, and this is actually of a black hole. So this is the black
Oh.
hole's, what they call the shadow of the black hole. It's the
Mm.
area where light cannot come out because the universe in that region, the fabric of space is warped so deeply that the light can only circle around inside that well and can't get out and come to your eye
Wow.
anymore. Now, what you're
Wow.
looking at here is a disk, okay, of material around the black hole. And you might say, wow, it seems like we're looking down on top of it because I see the disk. But
Right.
in fact, every way you look at this from every single direction, you'll see it like this. Now, wait a minute, Mark. Why would
That's
that?
strange,
How
yes.
could that happen? The way that can happen is very simple, and that is that when you have a large gravitational field, the
Mhm.
light on the far side of this disk, which is, think of it as a disk of material, and let's say it's coming toward us like this, or like on a slight
Okay.
angle. The light coming up from the material on the far side, as it comes up, it's getting bent. It's warping and following the curvature of space, which is being deeply bent by that thing right there, the black hole.
Mm.
So the light arcs over the top and comes to our eyes. Okay. And the light that's on the near side is accentuated in this way. So this tells us this stuff here, or in the bright, sorry, or the bright way, that's
Right.
moving toward us, and this stuff
Okay.
up top is bending toward us from the backside. This tells us the exact plane of this black hole right here as we're looking at it.
So
Now,
would it, if we looked at it from a side or above or anything, we'd still see the same thing, or just within that disk?
exactly.
Okay.
No, any
So
way you look at it.
there really isn't a disk. It just appears that way.
Well, actually, there is a disk, but no matter which way you see that disk, it's going to look like this from wherever you look at it from
Hmm,
space.
that's
Okay.
amazing.
And that's because the disk is always there, but the light on the far side, we can't see unless it tries to go up. And the light that goes up is going to be a fraction of what's going out every other direction.
Right.
So it goes up,
Cool.
and some comes over the top because it's following space, which is warped over the top of the black hole. And so we see
Mhm.
the light coming over the top like that. And it's fainter because it's only some of the light. On the
Yeah.
near side stuff over there, we actually see more of the light coming at us because that's on this side and that's not near the black hole. Okay, it's on this stuff is on this side of the disk of the black hole and not on the other.
Right.
Yeah,
Right.
so that's
That
pretty
is
cool.
so cool.
Yeah, that's how
It
this
looks hot.
looks. Yeah, very haunting. Okay. Yeah. So as we see, okay, this shape you see here was
Yeah.
accurately predicted. It was very accurately predicted, and I guess when they did the movie Interstellar, astrophysicist Kip Thorne was consultant. He was the consultant, and when they said, "What's the black hole look like?" he used Einstein's theories of relativity to figure out what the shape of the black hole should
Wow.
be, and that's what he came up with. Now, Kip Thorne's brilliant. I sat with him for 3 hours and talked to him about black holes one time. And, I went down there to his place and he talked about time travel using black holes, but it really wasn't real time travel. It was information that's being provided. Black holes mess up everything you know and understand about the universe. They do.
Makes
And
sense.
yeah, it
Aren't they
does. It
the most
makes
destructive thing?
yeah, it makes sense that there's no sense to
Mhm.
them. Yes, exactly right.
Yeah.
Yeah. They're not intuitive, not at all. And so that's what's interesting. So
Yeah.
black holes do have a fascination for a lot of people. Okay. So we understand black holes. We understand those things. We understand again, this is the most recent crazy mystery that we've kind of found that we can understand. But what about when we don't understand something? You know,
Mm.
and it tries to mess us up every time we turn around. Okay. So considering that, let's talk about the expansion rate of the universe, though.
Mm.
What's that mean? Well, the universe is expanding. Okay. Expanding? Yes, expanding. Ever since the Big Bang, the universe was expanding outward
In all
and
directions,
in all
right?
directions, right? From the
Okay.
spherical, so it's going this way, every which way, all directions. Now, in looking at cosmological studies now, the current consensus is that the universe is 92.6 or 93 billion light years in diameter. Now, wait a minute.
Wow.
We look out, we see the cosmic microwave background, and it's at 13.6 billion light years out that we can see it. So why isn't that the limit? The cosmic microwave background is the background radiation that's still somewhat opaque. That's like back at the Big Bang.
Mm.
Yeah, the universe is 13.8 billion years old. And so we're seeing out that far because in the time
Yeah.
we've been around, that's how much light could reach us from 13.6 or so billion light years out. That's how long. So over the last 13.6 6 or 8 billion years, that light's been coming to us. And so we haven't seen it yet. So when we look out there and we see something 13.6 or 13.8 billion light years away, that's the limitation of our universe. That's our observable universe.
That's the edge
for us, but it goes on much further. But that light hasn't reached us yet. See? And so think about this. That light out there, I say 13.6 because we can't see to 13.8 because the universe was opaque back then. And so that means that nothing was getting out. Okay. The universe was actually uniquely opaque back then because we didn't have atoms. We didn't have material that would actually shine effectively. Think of it that way. So once things began to form atoms and so forth, that's where the cosmic microwave background is visible. And that was at 13.6 billion light years out. Now consider that in the time it took that light to get here, from 13.6 billion years ago, okay, all that time, the universe continued to expand outward on the other side of it. Okay. So there is the notion that this expansion just kept going while this other material was getting to us, and we still haven't seen beyond it. Keep that in mind, because now we also noticed that the expansion rate of the universe, which was thought to be a constant, turned out that it's not constant. And that constant was found by Edwin P. Hubble in the 20s, and it's called the rate of expansion, the Hubble constant, and that was a certain value. And it turned out that value wasn't constant after all. It turns out the universe is expanding faster every second. Okay, it's almost like the explosion is just occurring. So how do you explain that you have the universe expanding faster and faster and faster every second? Well, the answer...
I was going to say, was it an error in his calculations?
No, his calculations were sound for that moment. That was the expansion rate. So what happened? What happened is that there is another force out there that we never knew was there, another energy. And by the way, there are people that say that this dark energy thing doesn't really exist. Actually, it does.
It has to.
It's just been changed. They've changed the way it is because it turns out the amount of dark energy in the universe is changing. Okay,
because of the expansion?
Yes, the expansion is causing the dark energy to reduce in intensity over time. And so the universe is far more complex than we ever really imagined. And I think that's what's cool about it. But how could the universe be expanding faster and faster, right? Imagine this. Now, let's understand the expansion of the universe with a little model. Take a balloon, blow it up to about a softball size, take a Sharpie and put dots all over it. Make the dots all, a half inch from any other dot. So you have this, measles infested balloon that's blown up a little bit. Okay. Now keep blowing it up. As you blow it up, every single dot moves away from every other dot on the balloon. See, as it's expanding, every dot moves away from every other dot. Okay. That's a model for the expansion of the universe. Now that's happening in 3D, but consider that with that concept comes the notion of an expansion rate that's even faster than that. So everything is expanding faster and faster and moving further and further away from itself, away from any other object, faster than before and faster all the time. That was a conundrum.
Yeah.
Because it means that the Hubble constant wasn't a constant. And it means that something else had to explain it. That's right, Tara. So what did they do? They came up with what may still be a cosmic fudge factor, but it does explain the observations. And that was called, as you see there, dark energy. And dark energy is a material that's out there, an energy actually, that is a repulsive force. It's actually pushing everything away from everything else at a very, very high rate. Okay. Driving space apart ever quicker. Interesting stuff. Now, we don't know what it is. We can't see it. We only infer its presence by looking at the expansion rate of the universe. Okay. So This is a major question in the universe. This is like stupendously, colossally impossible to figure out right now. We don't know what's causing this to happen. We don't know where dark energy really comes from. You see,
Is it the opposite of gravity? I mean, the yin and the yang?
in effect, it's sort of like that. Um, I know Karen asked about white holes versus black holes.
Right.
Okay, that's the yin
Good
yang
question.
concept brought
Mhm.
out to a celestial scale.
Yeah.
Now, when I talked to Kip Thorne years ago, he said something about white holes. He basically used white holes if they exist. We would actually see our ship coming out of a white hole if they were the exit from a black hole. Before our ship actually went into the black hole, we'd see our ship coming out of the white hole. Is that not time travel in a sense?
Mm.
In a sense, it is, but it's not really our ship coming out. It's the information based on the extreme bending of space time, okay, that allows us to see that ship coming out before we've actually entered. It's just the information. It's not the actual ship. That's a tough concept, and I grant you it is. So keep in mind as we move forward now.
Okay.
Again, we don't know what this stuff is, right?
Right.
So, is there when you say dark energy, is it like the yin yang of gravity? Maybe
Hmm.
it's a repulsive force. Gravity sucks,
Right.
right? That's
Right.
the that's the,
Literally.
that's the joke, right? Like gravity sucks. And in physics terms, what does that mean? It means that there are particles we may not understand in gravity, things called gravitons. Now, Einstein never thought we'd see gravitational waves. People have heard me say this 1,000 times. Um, but we found gravitational waves,
So
ripples
cool.
in space time, ripples in the fabric of space. But wait, Mark, space is empty. Yes, you might have a vacuum in space, but what you have is something else. You also have in this emptiness of space, you have a ability for gravity to warp it. Okay, strong enough gravity will fold
Mm.
space in on itself. So there's a two-dimensional analogy to what it looks like when you take a bowling ball and put it in the center of a stretched out rubber membrane. It doesn't just sit flat. The bowling ball
Right.
goes down. You see this deep slope. If you throw a marble in there, it'll go, and it'll spiral faster and faster until it hits the bowling ball. Okay, that's effectively what a gravity well looks like. But now in 3 dimensions, it's everywhere around the black
Cool.
hole. So
Wow.
it's a much more complex shape, relatively speaking. And the well is something you can't visualize in 3 dimensions in your head. But that said, okay, that's what gravity is. We know what it is, we know the value. The formula is the force of gravity between two objects is capital G times the mass of the big object times the mass of another object over the radius between them squared. F equals GMM over R squared. That's the force of gravity calculated between two masses that you know the masses of. G is a cosmological constant, a number, never changes. That one doesn't change. Okay. So we know that we can calculate the force. Being able to calculate the force of gravity took us to Mars many times successfully. Took us to Pluto with the Event Horizons craft. Took us to
Cool.
Ceres, the asteroid, and Vesta. Okay, Ceres is a water-rich asteroid. Vesta's dry as a bone, and that took us out there. We were able to go out there because we could calculate gravity. Every space mission, the ISS in space with the astronauts going up in the Dragon capsules, all that means it comes from the fact that we can calculate gravity. Do we know what gravity is?
Mm.
No, we don't. And
Right.
that's what's neat. See? Does this make sense?
It makes sense. It is neat, but it's not. I want to know because if we could figure out gravity, we could figure out dark energy, right? In
I think
theory,
that
maybe.
in theory it might be related and it might be, as you say, like a yin yang to gravity.
Mhm.
I actually love that analogy. I never thought of it until you said it.
Hmm.
And when you said yin yang to gravity, um, that's like, hey, that's a good idea, you know? And so you'll have to tell me where you got your astrophysics degree because that's really cool. Good thinking. No, so the bottom line is that we don't know what this stuff is. We don't know what this repulsive force is. So the expansion rate is truly an accelerating rate, and we don't know why. So that's kind of incredible that we don't know why it's doing that. We do know that it makes up 73% of the observable universe. Isn't that
Wow.
crazy?
It
Yeah,
is.
yeah. Now, space does act like other mediums. It acts like water in that you can see ripples in space. It acts like um,
Cool.
it acts like uh, light and water in a way because we can see waves moving through. We see gravity waves. Okay. Um, we can see that there are distortions in the universe that occur from gravity. Okay. Well, just like you have distortions in if you put a rock in a river, a big rock in a river, the water flows around it. Okay.
Right.
Well, we see that kind of disturbance when we look at objects on the far side of that rock and we see the water coming around both sides of the rock. Well, the water's coming from one place. When it gets to the rock, it splits and then moves around the rock, right? Well, that's what we see in space when we're looking at instead of a rock, it's a giant galaxy cluster, and on the far side is another one, and
Hmm.
we see the light from that far galaxy cluster getting moved around the rock, so to speak, around that nearby cluster. That's a
Cool.
gravitational microlens. We see
Hmm.
gravitational lensing as the water or the light from these distant galaxies is going around the nearby set of galaxies and being distorted into a shape of like a ring around that galaxy. See, so the space acts like other mediums in this regard. So it's actually kind of cool
It
when you think
is.
about it. Yeah. you know Now, other things that we don't understand
Hmm.
are things to do with galaxies. This is another Messier 31 galaxy. It's 2.4 million light years away.
Beautiful.
It is, you
Hmm.
know and it's again full of what could be up to a trillion stars.
Wow.
Compare that to our 150 billion, at the high end 400 billion. Okay, that, I mean, still, 1 billion's a lot, never mind 150 billion in our galaxy, or trillion like this. Okay. So, but the thing is, when we study
Right.
galaxies, you see there's rotation. We've orbited our galaxy 19 or so times in the 4.6 billion years we've been here. And there's a rotation rate, a speed at which we're going around the galaxy, right? There's a speed. And we know that speed. That takes us around 19 to 20 times around the galaxy in the time we've existed. Now,
Right.
if you measure the rate of rotation of galaxies, you expect that to obey some physics laws, okay, like these. When
Okay.
planets are orbiting the sun, right?
Hmm.
If you look at Mercury goes around the sun pretty fast, doesn't it?
Right. Makes sense.
Yeah, because
We're
it's
close.
closer. So, right, so
Hmm.
it's got to go faster to stay in orbit.
Right.
Okay. Well, Pluto, way out there, and Pluto is a planet. I don't care what anyone says. Okay. When Pluto way out here, it takes over 200 years to go around the sun. It's going around leisurely and slowly, but it can stay in a nice orbit, moving that slow out there. Why is that? Because it's further away, and the forces acting on it are not as great as they are on Mercury. So, doesn't that apply to galaxies where stars closer to the center should be orbiting like mad, and stars way out on the outside, okay, way out there on the outside, should be kind of just leisurely going around slowly, right? Isn't that
Y-
what it should be?
You would think it would be consistent.
You would, wouldn't you?
You would think.
Yeah. Well, unfortunately,
Not.
they do not decrease further out at the rate that they should.
Well, well,
It's
why
just,
should the rotation be the same? When you say on your thing, galactic rotation should be same
oh
between
yeah,
the
yeah,
nearest and
yeah,
furthest?
yeah, because yes, exactly. The nearest stars to the center of the galaxy should be moving faster around the galaxy, and the
Well,
ones that are further away should move slower.
right, but when you say they
Mm.
should be the same, what does that mean?
What I mean is, the rotation rate of stars moving around the galaxy should follow the same model. The
I
ones that are
apologize.
closer to the
Okay.
center
Yes.
should go faster, like Mercury going around the sun. And if
Right.
the sun is the center of the galaxy, kind of a thing, right? If you think of the
Okay.
analogy, sun and its planets to galaxy nucleus and its stars. Okay.
Thank you. So
And the
then
farther out,
what
it should move
happened?
slower, right?
Mhm.
Yeah. Well, it doesn't follow the model like we expect it to. And so what happens is this is a curve. This is the actual curve. The velocity on the left side there is in kilometers per second, and it goes from 0 to over 100. And if you look, you'll see that when we look at starlight and we analyze the speed of the galaxy's stars moving around the galaxy, you'll see that they are actually they're not dropping off as they leave the center of the galaxy. They're actually covering more ground the further out they go, but they're not really accelerating very fast or dropping off. They're actually acting like this galaxy is a rigid disk, spinning like a rigid disk.
Mm.
Not quite though. The stars on the outside are moving slower, and so they do lag behind a little bit over the central stars, but they're not doing what should have been observed, like the dotted line
Huh.
down below. That dotted line down below shows what it should be. Okay.
Right.
And we don't see that. That's not what we're seeing. So clearly, when we look at these, if we measure what's called the 21 centimeter band, which is neutral hydrogen, that's in the blue up there, that's
Okay.
moving around the galaxy, and we can measure the speed of its motion. We know where that spectral line exists on the
Oh.
spectrum, and if it's shifted one way or the other, we can figure out what that means. If it's shifted toward the blue, it's coming at us. If it's shifted toward the red, it's going away from us. Put all the data together with all your observations, you can figure out whether the hydrogen is actually moving in one direction around the galaxy, or faster or slower. And so by
Okay.
mapping those and graphing them out with exhaustive work, this is what you see. Okay. This
Nice.
didn't make sense. It shows us that there is um, some kind of other physics at play out there
Mm.
that creates the oddity that we're seeing here. Galaxies appear to rotate as a rigid disk. They shouldn't. We should see the stars going slower the farther out they are, but they don't. And
Huh.
so that required us to look at galaxy structure and try to figure out something deeper. And what actually happens here is that the only way um, to figure out what's going on is to add yet another parameter,
Okay.
something called dark matter, not dark energy. Dark just means we don't understand it.
Something else we don't understand.
That's right.
Mhm.
Because it means that dark matter must be present. It's like a halo around the galaxy, kind of dragging everything along a little bit.
Hmm.
And as it turns out, we can't accept any breaks of Newtonian physics, which is what governs all of the mechanics that we know. So we say for now, until further notice, that dark matter is 23% of what we see, and dark energy is 73%. Look what that means.
Wow.
It means that we only understand 4% of the universe. Let that
Wow.
let that sink in. We only understand 4%. And in knowing just that 4%, look what we've been able to do. Right? We've gone to the moon. We've gone to Mars.
Humankind's amazing. We're great.
Yeah, we are. We
Mhm.
actually have a quite
Mhm.
a quite a good handle on what we do understand of the universe. That
Right.
4% got you covered. Well, maybe not. There's a whole bunch of things we don't understand in that 4%.
Yeah,
Okay. But still, if you think about it, that's really cool.
it is. No wonder I still
Yeah.
have a lot of questions.
Yeah, you do. And for people listening, of course, you probably know what she does. I mean, she used to write these questions and ask these questions, and we gave her own segment on the show just to ask the coolest questions, and she still does it. But now we're not going to make her wait to the end. She can interrupt me at any time and
Thank
ask
you,
a
Mark.
question anytime. You know? Yep.
I appreciate it. Thanks.
Oh yeah. No, I like it better now. I know I'm kind of lecturing. I'm not giving you much of a chance to talk, so I want to give you a chance. Um,
This
uh,
is so fascinating to hear, and the way you explain it, it helps all of us understand. So it's just cool. It's just cool.
yeah, stuff that we don't normally follow and understand,
Uh-uh.
right? Now,
So yeah.
that final 4% that we do understand, that's what we call baryonic matter. That's You know, the protons,
Very unique.
electrons, muons, gluons, and so on. Okay.
Mm.
Yeah, and now we understand how atoms are built, right? Protons are made of quarks, 3 of them. Okay. They have 2 up and 1 down quark. Yes, I know those are weird words to associate. And what's worse is they they have a fractional charge on them. A quark is an up quark has a charge of 2/3,
Oh,
not 1 or 0, 2/3. Okay, a down quark is minus 1/3, and a proton is made of 2 up quarks and 1 down quark. So that's 2/3 plus 2/3 is 4/3 minus 1/3 is 3/3, which is 1.
one.
So the proton has a charge of 1. Okay,
Wow,
see?
that's incredible.
Yeah. And a neutron is made of the down quark. It has a down quark in there. So it has an up quark of 2/3, a down quark
Okay.
of
Minus
uh,
one.
no, a down
Uh,
quark of let's see, it's okay. Oh yes, up quark, 2 down quarks, and 1 up quark. Okay. And because okay, right. So that gives us a charge of 0 on the neutron. Okay. And so now those particles show us why we get charges and so forth. Okay. Now the electron, that's a
hmm,
weirdo. Okay. That's a lepton, and that guy, it's a
okay.
fundamental particle. And as far as we can tell, it's not made of anything smaller. Like protons are made of smaller things.
Hmm.
Electrons are not. They're fundamental particles in their own right. Really kind of interesting. So anyway, that's neither here nor there. But the problem with the 4% we understand that I've been telling you about is that unfortunately, half of it we don't see. Okay,
It's
so
missing?
it's sort of missing. Yeah. So effectively, there's 2% of the universe that we really understand, and 2% we think we understand but can't really see it. So and that's after all the time we've been here, um, uh, evolving from Australopithecus afarensis, Lucy, or just over
Yeah.
4 million years ago to today. Um, but that's actually kind of speedy, I guess, in terms of evolution, you know. Um, but the problem is, it seems to it seems that some of the mass is missing, and if
Hmm.
so, it means that maybe there wasn't enough mass to make the Big Bang occur.
Well, that couldn't
So,
have happened,
because
or
we are
could it?
here,
Yeah,
Mm.
we are here.
Well,
That's
maybe it's
odd.
possible that we're a small off a main boom. You know what I mean?
A
Uh,
bubble, like the bubble
like
universe,
a
sort
little
of.
spurt off of a main universe. It
So,
depends on how you model the
oh,
universe. Go ahead.
that's an interesting thought, though, what you're saying.
Yeah,
Yeah.
and think of it this way.
Hmm.
We've noticed sometimes things in physics that occur, and the things in physics that occur sometimes are mimicked at a macro scale. So when you fill a sink with soap and you run the water really fast, it makes suds, right?
Right.
Okay, we don't create the suds. Those suds are created by the physics of the situation with the running water hitting the soap. And you can go into the
Okay.
physics of how suds are made. But the shape of the sud is something interesting. On the outside, it's a rounded shape, but on the inside, where it hits other suds, it's a flat facet. Okay. So it's
Oh,
not a ball. Okay. It's flat when it reaches. You've seen this with soap bubbles when you blow soap bubbles. When you
yes.
put them together to make two, you got two round balls, and in the middle is a straight line, a wall. Okay. Physics at it again. Okay. Now that has to do very likely with the law of minimal surfaces and surface tension. But think of it this way: when you have a universe at a macro scale, if you had more than one universe packed into your sink, wouldn't you also possibly have multiple soap suds universes around you? And if so, might some of the energy required to make your universe be leached off of the main soap sud? Possibly. The flat
Yes.
faceted side could be the consequence of being near this other universe, thus reducing the energy needed to make your universe. So maybe we're going to
Oh,
get to the point where we're going to see at some point how that all might go together. That's pretty cool.
Wow, that's amazing. We have 2 minutes till break, but
Yes, we
is
do.
is that flat, faceted area what we're seeing on the cosmic microwave background, those areas that are lighter, or I mean, cooler or
Well,
hotter?
I know what you mean. Unfortunately, you have to keep in mind that our observable universe is only 13.6 billion light years or so in distance. And then that's the cosmic microwave background, right? But the universe that we know is 92 or 93 billion light years in diameter. It's way bigger. So the facets would be
Right.
way out there, way
Okay.
far away and distant, so much further than we could ever see, counting how long our sun has left to live and so forth. Um, we would not see much further. Now, if we look at in the future, say 1 billion years from now, the sun has another 5 or so billion years.
Mhm.
Let's say 1 billion years from now, humans were at the same level we are now. They wouldn't be, of course. If they
Hopefully
looked
not.
out, yeah. Well, to them, their universe might be 20 billion light years in size, or 22 billion light years in size, because by
Mhm.
then, you know, some of that additional light will have come in. Okay,
Right.
13.8. So maybe, well, it would have
Mm.
to be, it wouldn't grow that much. It'd be like 14 billion light years in size, or 15 at the most, by the time that turned around. So it's a very slow moving window of size
Mm.
increase that would be seen. So it's pretty cool.
It's
Yeah.
amazing.
Yeah, it is. So anyway, I think we can hold off here, and when we come back,
Mhm.
I think we'll get into some interesting phenomena that occur with people and
Okay.
their views of the universe. And not this is again more mysteries, but they're mysteries that deal with us. Ooh. So
Cool.
more later when we get back.
Awesome.
As UFO reports come in from around the world, the Mutual UFO Network, MUFON, is there. We continue to explore new cases and build our massive database. We share our information with the world in a number of ways. If you would like to be part of our investigative team, you are always welcome. What could be more exciting than exploring the UFO question firsthand? Join MUFON, find your friends.
Hello, welcome back.
Hello.
How you doing?
Hey, good. Good. Great.
Okay.
Hey, that was a great commercial. That was
Oh,
beautiful.
that was neat. Isabella in our chat did
Mhm.
the Sky Tour shop one, and I did that last one, which was the summary of the Benson, Arizona building on the mountaintop there with the rest of the astronomers. Every one of those observatories has a professional astronomer set up in it, which is really cool. So it's nice that it's like going home. You know, I actually joined the elite cadre of astronomers. You know, the ones that have pants that are too short with white socks, um, and nerdy glasses. I've got those, but I don't wear them during the show. But I got them. See,
Oh,
yeah,
yeah. There you
yeah.
go.
No, no,
I
you're
wear
all set.
mine.
Yeah, you're all set. Yeah, you look good in yours though. So you know. So yeah. So in part two, I want to talk to you about. And again, like I said, Tara, at any point you interrupt me because you're allowed to. And if people have a good question that I don't see, go ahead and throw it up there. You
Awesome.
know, I know Chanel, our wonderful producer, she's throwing some up there as
Yeah.
well, and I really, really, really appreciate that.
She's awesome.
I want her to come on and take a bow actually because she's just the unsung hero.
Yeah.
If she's out there, if she hasn't fallen asleep, right?
No,
So
she's working hard, I'm sure.
I'm sure she is. Yes.
Mhm.
Yeah, but she's behind this icon here, you know. Pressure's on, Chanel. Time to come on and say hi.
What's
Yeah.
up, everyone?
Oh, there she
There
is.
she is.
Had to clear my desk here. I've got all my.
Oh, I see. Yeah. Okay.
We didn't give her any warning.
I didn't.
Got to turn the speaker volumes down. Put the
I
headset.
know. You know, hey, the bottom line is that sometimes I'll do that, but I want people to see who's behind the scenes down there.
We sure
Okay.
appreciate you.
Yeah. Yeah. Thank you. I just wanted to, you know, and you can take yourself out whenever you want. You can stick around. I don't care.
Well,
Yeah.
I must say before I head out, fascinating show so far. I'm enjoying
Hey.
all of this
Excellent.
information, and it's a great refresher. So yeah, I hope
Oh,
everyone else is enjoying it too. And if it's okay with you, I'll hop in the comments and say hi to everyone there too throughout the show.
well, please do.
Awesome.
And
Awesome.
thank you for bringing stuff up for us too.
Yeah, thanks,
Good to
Chanel.
see.
Happy to
Yeah.
help.
Yeah, she always seems to know where we are, and she does the right thing. She never brings up anything that's inappropriate. You know what I love, and you know, like not part of the conversation.
It's almost like she does it for a living or something, like she's a professional or
Oh,
something.
don't go that
Oh,
far, right?
yeah, almost. Yeah.
Yeah, she's really good.
She's
Yeah,
awesome.
yeah. And because we changed our day to Wednesday, that's why Bill New York Skywatcher can't be our
Yeah.
producer. Equally talented, does equally as good for us.
Love you, Bill.
Yeah, we do. He's a great guy. All right, so we're going to talk about unexplained phenomena again, but this is part two of that
Okay.
run through. So we
Part
want to talk
two.
about things. We saw the astronomical phenomena. So what
Mhm.
about subjective human experiences? These are the things that everybody in the chat here can understand.
Oh,
It's
yeah.
why they're here. Part of the reason why they're here. Now, I'm an astronomer, and as an astronomer, I'm not supposed to say that I believe alien life is here. I'm not
Don't
supposed to
say
say
that. You're not supposed to say that.
they're supposed to toe the dogmatic line that I'll believe it when I see it, kind of a thing.
Mhm.
But I do believe I see how it can happen, and that's the subject of my talk, which is not tonight, on interdimensional travel. You and I actually did this show already, Tara. You remember we did that show. We talked about the interdimensional travel mechanism.
Yes, that was
Yep.
very interesting. Mhm.
Yeah, and so that's the way. That's actually on our Sky Tour live stream YouTube channel, by the way, guys. So, as will be this. Um, when we talk about subjective human experience, why do we give that any more credence than someone who makes a claim that they saw, someone that wasn't there? People are found to be lying in court and stuff all the time. So why would we believe anybody? Well,
Right.
the answer comes down to we have to carefully vet what they say. Yes, we have to, and we have to be very careful about what people say and very careful about what we just instantly believe. But it's very important to sometimes just listen to people talk. And you can tell a lot of the time when people are talking if it's something they actually believe. And having been in this business since, I hate to say it, 1971. I know. Oh God. Yeah, I joined MUFON in 1971 when it was called the Midwest UFO Network. And that was 2 years after it formed.
And how old were you then?
I was 11.
Yeah, I was going to say you had to be little.
I was 11.
An astronomer by that time, though.
Yeah, by 11, I knew I was going to be an astronomer. Yeah.
Yes.
Yeah. I mean, I wish I could say I was still a fetus when I joined, but I can't because I didn't have hands. They were more like little nubs.
Oh my goodness.
Okay. Yeah. But the bottom line is that I've seen a lot of things, heard a lot of people make comments. I've heard a lot of liars, and I've heard a lot of people that are passionate and truthful. Okay. And when I smell a liar, and I can prove it, I don't hold back.
Yes,
Okay.
I've seen that. That's true.
I outed Stephen Greer. I outed Stan Romanek. Okay. And I don't have any mercy on people that I think are lying. Okay, because they're actually muddying the waters of the science that this should be. And that's the problem I have.
Yeah.
So that's how I feel. And so the subjective human experience requires you to be very critical in your thinking, much more so than looking at a photograph or a video. When people are telling you about things, you have to really understand it. You have to understand how people think. And that's something that I've been, I guess, reasonably good at over the years, right? So in the past, talking about subjective experiences, we discussed the possibilities that maybe with the soap suds, we talked about potential other universes, right? And the fact that our universe maybe was a little pop off of a bigger bang, right? And with a flat facets, you don't need as much energy. And so maybe the energy required to make our big bang didn't require as much mass, didn't require as much energy. So maybe that could come into play sooner or later down the line. Okay. But this is a good question. In another universe, what or who might exist? Okay. Now, I had my own experience with this that I think is true, and that was the ghostly dog episode. Now, I actually was wearing a monitor on my brain because I was seeing and hearing things that weren't actually there.
Wow.
Now, I'm not afraid to mention that I did have brain surgery about 27, 28 years ago. You can still see the scar in the top of my head. It went all the way across.
Wow.
And yeah, they had to put a brain in.
It's about time.
It didn't work real well. Okay. But yeah, I had a tumor dead center in the head. It wasn't cancer. It was a cyst, actually, a fluid-filled sac. And they had to remove it. And if they just pulled out the fluid, it would have filled up again. And usually what I had was something they find on an autopsy. So this wasn't something that I wanted to play around with. So
Wow.
After that was over, about 22 years passed, and I started hearing people talking. And it was so bad that I'd be sitting in this chair and hearing my kids upstairs right above me sitting on the couch talking. I'm like, it's 11:30 at night. What are they doing up? And I get up and I run upstairs to an empty living room with nobody in it. I run upstairs again to their bedrooms. I open their door. I look in. They're sound asleep in their beds. Okay. So I was like,
Very strange.
And that was the start of it. And then I started hearing people talking right behind me and right next to me. And it's like, wait a minute, am I going nuts? Are they going to start telling me to kill my dogs or something? Is this, what's next? And the answer came soon after, because I not only started hearing people talk, I started seeing things. I started seeing people that weren't there. And the noise when people talk, and this is, by the way, something that goes on to this day. I hear it all the time. Never goes away. It's really hard to sleep because I go to bed with everybody. Okay, there's people talking all the time, and they're not telling me in particular anything. What's that?
It's not telepathy you're hearing. Are you hearing?
I don't know. Spock, I don't know.
People with telepathy, I've heard sometimes can't turn that off.
I can't turn it off. I don't think it's that. I don't know what it is.
Mhm.
But give you an example. I sit still. If I take out my earphones and I don't have something going like a heater or something making generic noise like a fan or
Right.
something, I hear people talking in the room. And it's always distracting. I'm always turning my head. Who's that? Thinking I realize it's not real. But all the things they're saying are not anything other than ordinary conversation. So for the longest time, I thought my brain was just replaying stuff I heard before because of the brain surgery. I thought my brain was
Wow.
just replaying conversations it overheard that maybe I didn't consciously remember. And so I live with the concept that maybe my brain is in a mode where it's in replay mode,
Right.
playing back all this stuff it heard,
Wow.
and then I started seeing things that weren't there. And I thought, wow, my brain has now graduated to showing me images of things that I saw but don't remember. So I thought it was replaying now imagery that I saw. And that took me to a neurologist. I told him what was going on. He went through this elaborate drawing on the board about chemical voices, chemical stuff that could cause voices to sound off in my head or whatever. But he had no answer. He didn't really know why. Okay, and Isabella said she has that, and
Mhm.
Donald Kunzer says they hear that. And so medically, I don't know what was wrong, and neither does medical science. So what they did was they put this big kind of harness on top of my head, and I had this gigantic bunch of cords coming out of the back of my head. I looked like Locutus of Borg. I am Locutus of Borg, and it was sticking out the back. I got photos of this. I should show them if I could find them.
That's cool.
Yeah, and then when when I actually started seeing something, they said to me, we'd like to we'd like to have you make sure that you hit this button and show us that something happened. Okay, hit this button so we can see it. Okay, and if you can do that, then we'll be able to make some heads or tails of what you're seeing. And I was like, okay, why not? I
Sounds
guess.
easy. Yeah.
Sounds easy. Yeah. So I ended up saying, all right, well, let's go. So I went home with this thing on my head. I looked like a crazy guy in the neighborhood because I was walking around with this thing on my head.
Oh, that made you look crazy. Okay.
Oh, yeah. That.
Okay.
Wait,
Uh-huh.
what are you talking about? Yeah. Okay. But yeah. So the bottom line was this thing was actually not. I should say it didn't make a difference because I hit buttons when I saw stuff, and I saw all kinds of stuff. Okay, and it never went away. It kept staying there. It never stopped. And when they actually went to look at the data that I was providing for them, they saw very much so. They saw this nothing there. They said there was nothing there. Okay, this is what I look like right here. I'll actually show you.
Oh my goodness.
There I am, Locutus
Wow.
of Borg. Yeah, and that's a bundle of wires. So with all these electrodes all over my head.
Looks like a giant ponytail.
It does, but it's actually
Mhm.
going down to a computer at my side, and I had to carry that around too
cool.
for a day.
Huh.
And it's called a Holter monitor for the brain. Okay, and so when they looked at the data, they saw that there was nothing going on. Where I said I saw stuff, there was nothing there. So in other words, it wasn't a medical problem. It's another problem. So when I started seeing some people, I started also see animals. I'd see a little mouse skitter across the floor, and I was looking right at it, and there it is. It's like, wow. I'd see, but I could see through them. They're like translucent. I saw people that were translucent, and then I saw a dog walk into my shop when I was working on a model for a movie for a job I was working on. And it's 3:30 in the afternoon, and I'm looking at this dog walk in, and it's sort of bopping along, and it turns around and sits down, and I see a rhythmic action like it's licking itself or something.
Yeah.
And I'm going, it looks like a dog. So I walk over and I step on it, And when
What?
I stepped into the space that it contained, okay? And in the space that it was taking up, I noticed something fascinating. This thing, this little creature, it was just incredible because it got up and it ran out of the room.
Aw.
But when it went, it took my left leg with it. My left foot was like tied into it and I got yanked. And I could only hold back that tension for so long. And then my foot snapped out from under me, my left knee hyperextended, my right leg was pulled off. My right leg and my left foot, I could remember seeing them in the air right there, kind of like that. My right
Oh,
leg
funny.
here, my left leg there, snapped out and in serious pain. I thought I broke my knee.
Slow motion.
And
Yeah.
in slow motion. And then I hit my right shoulder on the bench, rolled over onto my left side as I was falling, hit my left shoulder, and then my head clack on the
Wow.
concrete. So I got like 5 injuries in one shot.
Wow.
And I got up and I was like, oh my God, that was incredible. It's like, oh, there's no one here to see this. Ow, ow, oh, this hurts. But this was
Yeah.
like, fascinating. What was this? It's incredibly cool. And I kept wanting to figure out more about what it was, but there was nothing I could do. There was nobody saw anything. Nobody was there with me, just me.
Yeah.
However, I had to go to the emergency room because I couldn't move this arm after that. And I thought
Oh my
maybe I
gosh.
thought I broke it. So I go to the hospital. They see me. And I didn't tell them I saw a semi-transparent dog. I said I fell against my workbench.
Well, no,
Oh,
you did. Yeah, you did.
I did. I didn't lie.
Yeah.
And they said, oh, you have we x-rayed it. It looks like you have a frozen shoulder. Okay.
Ouch.
Yeah, very much so. I couldn't raise my arm above this level here.
Mm.
And to do this was literally impossible. So I had to get higher and higher over time. And it took me about 5 months to be able to hang from my 2 hands again.
Wow.
Okay. So it had very real consequences in my world here. But I think that what I was looking at was a creature from a parallel universe.
Hmm.
You know, if you
The
think
less,
about it,
real
yeah.
quick, the lesson is don't step on dogs, whether they're real or ghostly. Just for everybody.
I'm a dog person, you know. I won't do
I
that,
know you are.
but the thing is,
I just step on it.
I don't step on dogs, and
It's-
I don't step on cats, even though I'm not a cat person.
Well,
Okay,
it's more the sense that you took that brave step to approach that odd thing. That's kind of more what I'm saying. Not necessarily that it was a dog, that you stepped on this thing that you didn't know what it was. That's
well, see,
that's
Catherine Messick says something important. Are you seeing into another dimension?
Mhm.
Donald Kunzer mentioned the Japanese tradition of
Right.
dogs, and cats actually seeing ghosts, and they're protecting the owners from them. Yeah, but what are ghosts? Ghosts are apparitions that appear to our eyes in our 4 dimensions. But can't they just be interdimensional views from a parallel universe? As Catherine Messick suggests, maybe we're looking at a view into a parallel universe. And I just want to say, like right here, quick, we'll come back. There's several different constructs for how a parallel universe acts, right?
Okay.
Multiverse, they're called, right? And one of them is the soap suds theory, where they're all bordered by all these flat, faceted things. Another is that they're concentric shells, like an onion, and they're always undulating. And as you see, like this finger is from this hand, okay, and these fingers here are down here, but sometimes the fingers mesh and parts come up above the other. You can see some from my right hand coming up through. Sometimes my left hand comes up. Okay, well, when that happens, if you're here and you're seeing this object right here, this thing coming through in your universe here, or sorry, your universe here, then if you see that thing coming up and you're in this universe, that might be the ghostly apparition to you that you see interfering and coming into your universe. And so maybe it's really something else. I coined a term that a lot of people have used, actually, called a parallel universe intersection. Okay. Maybe, yeah, PUI, a pooey, yeah, patooey, not a patooey. That's something different.
Pooey. Okay.
Yeah, a pooey. In French,
Oui.
play.
Way.
Play. Okay, but you got to do the le at the end. So this thing sticking up then could be an intersection from a universe down here that's popping up through ours for the moment, and where they cross, where they intersect, we can see that happening. Where they intersect, we see that, and maybe that explains why people all over the world, all the time, are seeing ghosts. Now, two things can be true at once. We could be seeing the departed ones, okay? Because there's nothing to say that interdimensionality is only for one thing. It could be for other things too, like ghosts and for parallel universes. The same phenomena can be supported by multiple sources. And so I think that maybe we're seeing, an incursion into our universe, okay, right here,
Right.
by something in another universe. Okay. And so if that dog was in our universe as a apparition and I stepped on it, it means there's actually a physical connection because I felt my leg being tugged right out from under me.
Right.
And it was actually quite frightening because I felt like it was going to try and pull me right through the wall. I mean, it was scary. And I wonder what would have happened if I took my second foot and stepped on it at that point and then crouched down and grabbed it with my hands. Would I have gone into that other dimension? I don't know. Probably not. I'd probably get slammed into the wall and they'd find me crumpled under a desk going, oh,
What happened to you?
Yeah.
Mark, well, question for you. Does that imply that the other universes are just like ours because they have, for instance, cats or dogs
what a
or
good
shadow
question.
people? I mean, how do we know that?
What a good question. We don't. We don't.
Mm-hmm.
Is it possible that there are other universes? Yes. Is it possible that they are like ours? Yes. Is it possible that there are a certain set of conditions that are available to other universes that aren't available to ours? Yes. Is it possible that carbon is the most prevalent one in another universe, an element? Yes. Is it possible that it doesn't exist in another universe? Yes.
Hmm.
All these things,
So, same as
So
dimensions? I mean, because they're the two different things. So things could be in universes that aren't in dimensions or vice versa.
something like that. Yeah, I agree. Yep. So you could have, oh gosh, you could have a dog that appears in our universe through a intersection. Okay. Now that dog might be very real to some other person in that dimension, and it might be in someone's living room. But if that dog goes through this incursion, and of course through no effort of its own, it's automatic because the undulations of the universe, mingling its borders with another one. Okay. Then again, this explains why people all over the world see ghosts for thousands of years.
Right.
Maybe their ghosts are actually parallel universe intersections. Maybe not. Okay. Maybe, no, I believe that's probably true. What I also believe is that ghosts might also be exactly what people think they are. Because people say they see their long lost relatives, all that. My mother saw a ghost, and my mother was no nonsense, Irish and Native American, very no nonsense lady, and she actually saw a ghost at her mother's house, which was in the backwoods of Maine.
Wow.
And my grandmother was paralyzed with arthritis from the neck down, but lived alone in the Maine backwoods. She could move her knees a little bit, and she could move her arms a little bit. She taped forks to eat. Okay. Well, her nurse's aide would put these gigantic lumps of tape on her forks so she could lift them up because she could only do this amount. So she'd eat like this. But she insisted on being alone. Went to the bathroom alone, washed up alone, and she could barely move. But she did it. And when asked why she was okay to live alone, she scoffed and said, "I don't live alone." What do you mean? Is there someone living with you? And she's like, "No, I no, not in that sense. I have the captain living with me." And of course, yeah, the captain. And my mother and father look at each other like, "Oh boy, I think dementia's setting in," or that kind of thing. Not at all. Not at all. Okay. She was sharp as a tack. And she said, "No." And she instructed my mother to go to the closet over there. She couldn't really point to it, but she went to the closet and she goes, "Now dig through that top shelf." I haven't been able to get there in years because she can't stand up. She's in a wheelchair. Our wheelchair, by the way, consisted of a plywood square with some posts and 4 wheels attached to it. That was her wheelchair. Just sort of glided around the kitchen on these 4 wheels. Okay. Well,
Wow.
my mother pulls out pictures from this, and in there is a photograph of an old sea captain. And my mother brought some pictures over and says, "Okay, Mom, which one do you want me to look at?" She's thumbing through them. "Okay, stop there, Millie." My mother's name was Mildred, Millie. Okay. And she goes, "That's him. That's the guy here." She goes, "Oh,
Oh,
are you kidding me?" She goes, "Nope, he takes care of me." She goes, "Well, that son of a gun," she didn't say gun, she said the other word. Okay. He was tweaking, my father was named Leo. He was tweaking Leo's toes yesterday, and I got up and yelled at him.
oh
"Stop
my
doing
goodness.
that." She got mad at him and yelled at him because my mother she didn't know. It was a no nonsense person. So she didn't care if you were a ghost. If you're doing something stupid, she's going to let you have it. No fear. And I think that's where I
Mhm.
got that from. So my grandmother said, "Yep, that's the sea captain. He lived in this house. He died in this house. He hasn't really left." And my
Wow.
mother said, "I saw him last night." And my mother said, "Does he have a pipe?" She goes, "Oh, yes, he smokes a pipe. You're right."
Huh.
Yeah. So it's a confluence of interesting anecdotal
Huh.
data, but you have to say to yourself, what if they're right?
Mhm.
What if they're right? Could people see? Could people see people that used to be here? Well, the answer seems to be a resounding yes if you ask around the world. Okay.
Mhm.
And so the point being that um, this phenomenon of the ghostly dog, I said ghostly dog in particular, meant because it could be an actual dog from a parallel universe, or it could be a ghost of a dog. Yeah. Sally
Yeah.
Ford says, "I swear I have things disappear and then reappear after I check 5 times in the same place." Yeah. And
Happens to me.
it ain't the ADHD. No,
Yeah,
I understand that. I
happens to
understand
me
that.
too.
I
Yeah.
understand that very much.
That's
Yeah,
true.
yeah. Uh,
Mhm.
so yeah, so that's the ghostly dog thing, and so those apparitions can have an astronomical background with the parallel universe, but who's to say that the ghosts that we're seeing aren't in yet another dimension that leaks
Well,
into our own?
dimension, universe, I mean, what are we talking? 2 different things, right?
Yeah, Isabel says that people see only animals and humans. It might have something to do with consciousness too. Yeah,
Mhm.
that's true.
Interesting. Mhm.
Okay. Yeah, because people don't see things like boulders and rocks. Okay.
Well, haven't there been sightings? I mean, you've heard stories that people were flying and they saw dinosaurs below them, or they saw the boulders and rocks and the terrain and stuff. So, but that's
Yeah,
just
no,
anecdotal, so,
yeah, I'm not sure what that is.
hmm.
Um, yeah, and people
Smells.
have smells. I have that too. Okay,
Mm.
and we joke about it. Say, "Oh, my mother's here."
Oh my goodness.
Yeah, because I don't smoke. No one here smokes. No one ever smoked here. Anyway, so yeah, that's kind of cool. So the multiverse concept can extend to ghosts as well as actual apparitions, which I think is cool. But we also hear about other distinctively subjective human phenomena, UFO sightings and crashes, for instance, right? I mean, that's very
Mhm.
important. So if we look at it, okay, we have whether in land or on sea, we have those. We have
Right.
abductions, we have missing time, we have implants, we have encounters with extraterrestrial beings, all those things. Everyone
Wow.
in the chat tonight is very familiar with these things because
Mhm.
even though they love astronomy, somewhere along the line, they've had some type of experience with something like this. Okay. And those of us who are unfortunate enough have had more than one.
Mhm.
Okay. And that's kind of bad. I've had an implant removed, I've had missing time.
Mhm.
I don't know if it was an abduction, but it was close. Okay. Um, I also had experience with an unknown submerged object. It went zipping by a submarine when I was on a sub as a guest of the Navy, not even a sailor. So a
Mhm.
lot of strange things. So UFO sightings and crashes, we have all kinds of them. We have the Advanced Aerospace Threat Identification Program, ATIP, that was out there. We have
Right.
thousands of encounters and sightings that people have heard about. And we have the Aztec, Cape Girardeau, Kecksburg, Roswell crashes supposedly, and these are all fascinating things. Now, are all of these things, are all these crashes and all these encounters, are they all wrong? Are they all wrong, and that it's just ordinary stuff that's mistaken?
No.
No,
Oh.
exactly right. Some of them are.
Yeah.
Some of them are,
But
but
all?
not all of them. I
Mm-mm.
can't. There's no
No
absolutes
way.
in science, really, except for,
Zero?
yeah, absolute zero. That's correct. I was trying to think of it. I can say, 0 degrees Kelvin. 0 Kelvin is an absolute. Yeah, that's an absolute. There are absolutes in science. So that's if you open your
Okay.
mind up and you allow yourself to be open minded, there's certain topics and expectations in science that you can't close your mind about, like extraterrestrial life. Okay. Now, objects seen underwater, like I just alluded to, in 2014, there was a case off the Swedish coast where something appeared in the harbor, and it was likely a Russian sub, but we don't know that. Okay. Then there was a Shag Harbor incident. I'll be speaking at Shag Harbor this year. I think
Ooh,
it's up
cool.
I think it's up in September or October. Martin Willis, good
Nice.
friend, he actually was the one that told them about me, and they were all excited. So I'm going to go speak up there.
Nice.
Yeah.
Thanks, Martin.
Yeah. Air Canada Flight 305, they saw things, at 7:05. They called it out. Okay. Daryl, and as you read here, you can just read. I'm not going to go reading everything because that's crazy. But yeah, objects moving through the sky. Okay. And then the ship MV Nickerson saw 4 stationary blips at a 28-kilometer location, and then looking out his window, he saw them visually in the sky. Now, when was this and where? Well, it was at a time when we shouldn't expect to see something hovering in the sky. Okay. Halifax Harbor.
Is never.
Yeah, I know. This is all about the Shag Harbor, right? This is
Right.
okay. So for Shag Harbor, Air Canada Flight 305 sees these objects. Okay, these folks see something. Okay, and then a ship out there sees something. Okay, Halifax Harbor, the Chronicle, Herald, and radio stations feel a lot of calls about something glowing
Wow.
and flying around Halifax around 10 p.m. They thought, oh no, an aircraft crashed. Nope, no missing aircraft. Was it a meteor? It may be, right? But I mean, we've talked about this before, I think. But it was seen over a couple of hours. Meteors are done and over at most in 15 to 30 seconds at the most. So what's left? A true unknown.
Right.
Yeah. So
cool.
the Condon Committee investigated it, and it's considered the definite analysis of events, and so forth. Okay. And the National Investigations Committee looked at it as well. Look at, I mean, what's the point? I mean, how much evidence do you need? Right?
So many people from so many different sources, and
yeah, and many were trying to put it away and say, "Oh, that's nothing."
Yeah.
Okay.
Nothing
we have
to
the
see
aerial.
here.
Yeah, like APRO, Aerial Phenomena Research Org. The final report said the study of UFOs would not lead to significant scientific discoveries. Okay, well, you can see my comment. Are you serious? Okay. So, all right. So the bottom line is, I had an experience on a sub. I told this many times. I won't belabor you with it because we only have a little while. But the bottom line is, I was a guest, and we saw something move through the sonar. The sonar operator, saw something move through the sonar at several hundred knots.
Wow.
Now that's several hundred miles an hour underwater. Now that's impossible for anything on the planet that we know of right now.
Yeah.
Okay. The only thing that can do it is a Russian torpedo called a Squall. It's actually a rocket torpedo. It's the loudest thing in the ocean, and this thing was almost silent.
Wow.
Okay. So it couldn't have been that. And some years after that, I had to do a job for the Joint Chiefs down in Washington. Right. I went down there to deliver the project. personally because I had to. It was a special project. And I
Fun.
sat with one of the chiefs himself. And one of the chiefs, I was in his living room. And we sat and I asked him, "Sir, what can you tell me about the potential for there being fast movers?" And that's what they called it on the boat, fast mover.
Fast mover.
Yeah. And
Mhm.
he said, "I'm sorry, Mark, I can't talk about that." Okay, no problem. And I drove back from Washington like unbelievably high with anticipation. I could not believe it, you know. So a lot of things out there, you know. Then we've had abductions, obviously, Barney and Betty Hill, Travis Walton, and some of you
Mhm.
who are out there listening probably know this as well and have experienced this kind of thing. Okay. So how come they abduct us? What are they looking for?
Hmm.
You know?
Good answer.
Well, if you think about it, what do? We do it with animals. We set up blinds, right? And we
Yes.
study the migration of elk and bears and platypuses, right? And we're intelligent, okay? So if an alien race is going to look at us and try to study us, I don't think they're going to try and put a big radio collar around our neck. Hey, Frank, you fainted. Yeah, I'm okay now, though. Big radio collar. You got any pizza left? Yeah, come on over
Yeah.
here, Frank. Not notice the collar. No, we are. So we actually, they have to use more clandestine methods for us because
Right.
we tend to know. Bud Hopkins was amazing about with this research. Okay, I talked to Bud for a very specific reason because one of my kids was being I'll say visited,
Mm.
and he had a big problem with it. And Bud said, "Bring him down here. I'll meet
Nice.
him. I'll talk to him. I won't even charge you." And so I was going to do that, but then Bud got sick and then he died. So I didn't get to do it. So we still don't have answers and we probably never will.
Darn it.
But he's older now and he doesn't care. He doesn't want to talk about those things anymore. Okay. But it's still out there. Now, as far as in my experience, I mean, some years ago, I was in the other house and I had 3 nights of terror where something came into my room. And on one night in particular, it took this glowing thing and shoved it up my sinus really hard. And it hurt. And I don't remember anything beyond that until the morning when I woke up and I had blood all over the place. And it took me 2 years to go to a surgeon to figure out what was up there because I couldn't breathe out of that. And he looked up there and said, "Holy cow." He says, "You got something huge up there." Not the kind of thing you want to hear from a surgeon.
In your nose.
Yeah. Yeah. And he says, "Is my head going to fall off?" You go, "No." He says, "But I think we can get it out." And so he took it out and it was this gigantic thing that came through that little tiny hole. Okay. And
Ow.
yeah, it was out. It was like Arnold Schwarzenegger in Total Recall.
Oh,
I pull it out. Yeah, I got it
yeah.
out. Right? That big round ball he pulled out, the ping pong ball out of his nose. That's what it felt like.
That's what it looked like.
Yeah. Well, anyway, he said,
Yuck.
"Call me in a week and I'll tell you what we discover in pathology." Okay. But I told him the story about how it happened, about 3 nights of terror where something shoved it up there. And he said, "Oh, I'm sure it's not aliens." And I laughed. Of course not. I wasn't so sure. Well, I called him a week later and the secretary said, "Oh, hang on. He has to talk to you." What?
Mm.
Oh gosh, it really is a head. My head's gonna fall off. Something's bad. He said, "Oh no, Mr. D'Antonio, sorry. I'm sure it's benign. So you're okay, okay?" Well, oh, you haven't heard from pathology? And I heard little crickets, and then for a moment, and then he said, "Well, this is something that's never happened in the history of my office, but pathology received it, signed for it, and it's not able to be located now."
Yeah.
Oh, okay. I didn't question him. Oh,
Oh
okay.
my gosh.
But you think it's benign? Yeah. Now, I had a suspicion. 4 years later, I went to him for something else. And on my intake sheet, well, what brings you here today, but all this stuff. And then for my occupation, I do special projects for the Navy. That's code for doing work for the Navy you can't talk about, which I've done for decades. Well, he sees that and he says, "Oh, special projects, huh?" I go, "Yeah." And he gets on the exam table with me. I'm like, awkward. Okay. And then he says, I just gave up my top secret clearance this year, he said to me. I went, what? He goes, yeah. He goes, I wasn't always a surgeon. And he got really serious. And he told me about a project he was on that required TS clearance. And sure enough, it does. And it turns out it was Project Starfish, which was done in the Pacific. And they launched a nuclear weapon up into space. And they said, well, it's to see what happens in the upper ionosphere if we launch nuclear weapons. That's what they told the public. What they were really doing was using the EMP pulse to take down an enemy satellite. And it worked. Okay. It was very successful, he said. Okay. Well, anyway, now I know what happened. Because when you have any kind of a clearance, what you have to do, if there's any national security threats or anything, you've got to report them. You're bound by law. Okay. Otherwise, you can be arrested. Okay. And you end up in Leavenworth or wherever. So I'm sure he called Washington, mentioned he had a patient that had some weird experience with what he thought the patient thought might have been aliens. And he got something up in his nose, which he did take out and is down in pathology right now. And they said, okay, thank you. And that was the end of the conversation. He doesn't really know where it went. And he'd pass a polygraph on that. He doesn't know who took it. He'd pass a polygraph on that. Okay. Navy likes to use polygraphs. And they do. I've had probably 10 polygraphs in all the programs I come in and out of in the Navy. And I'm as a civilian too. So he'd pass. So plausible deniability, he's going to be telling the truth if he says he doesn't know where it is. But that explains why it was lost. They came and got it, most likely. Could I be wrong? Sure. Maybe I am. I don't know. But that's something that's very interesting.
So next time, if that happens, would you keep it and take it home with you?
I asked him if I could keep it when he took it out. And he said, oh, no, I got to send it to pathology. And I said, well, yeah, I know. I said, well, maybe I can take it. No. And, I asked them, well, can you have him look in the middle of it and see if there's anything in there? I was thinking implant.
Yeah.
And he basically said, sure, but why? And that's when I told him the story about why I wanted him to look in the middle. And that's when he laughed about it being aliens and so forth. So anyway, that was that experience that I had. I don't know what else to say.
Wow. Thanks for sharing that. That's interesting.
Yeah. There's a lot of people too that have had missing time, Now, I'd like to say that missing time was something I've never had, but there's many reports of people losing time. And, it could be a medical reason or something, or it could be a real missing time situation.
Yeah.
My first missing time is why I'm an astronomer. Okay. Because I was 9 and I was on a field trip to a pond in Connecticut called Burr Pond. And when I went there, I was on the bus with my little bag lunch. I remember getting off the bus with my little bag lunch and my little polyester shorts. Okay. And next thing you know, I'm getting back on the bus in my little polyester shorts with my bag lunch. And I said to the kids who are now jumping around and going crazy, I said, what happened? When are we going to the pond? And they slapped me around and said, you idiot, we've been there all day. What? And I literally felt really sad because I missed all of it.
You don't remember it.
To this day, I don't remember any of it. I got home. I put my lunch in the counter. My mother said, why didn't you eat your lunch? I said, I don't know. Well, go out and play. I'll call you when dinner's ready. So I went into the empty lot next to the house. I was playing with a friend. Next thing you know, I'm feeling strange. And I collapse on the ground and I start having seizures. Okay. Oh. And during the seizure, I'm banging my head on the ground and I'm literally conscious, fully aware. And I'm whacking the ground with my forehead, hearing that dull thud you hear in your head when you get hit in the head. And it's weird because I remember seeing little red ants running around, thinking, oh, look at all the ants. How cool. The ants. And I'm banging my head in the ground, out of control. And I'm putting in dirt into my forehead, okay, that's being pushed in and breaking the skin. And I have a bloody welt on my forehead. And when my friend told my mother what was happening, they immediately called the ambulance. They took me to the hospital.
Oh, gosh.
Yeah. And in the ambulance, I said, hey, can you run the siren? It's like, I wasn't even concerned. It was like I was an observer,
You're
and
such a kid.
I was an observer. I wasn't frightened at
Huh.
all. I get to the
Yeah.
hospital. Doctor sees this welt on my forehead, and he says, "Oh, he got a concussion. That's why he had the seizure." No, the seizure caused that. But I didn't want to argue because I didn't want to deal with that. I wanted to just get home, and because at the same time, the nurse was taking tweezers and plucking dirt out of my forehead, and
Aw.
that hurt so bad. Do you ever get an abrasion and then you try to rub it and it hurts so bad?
Road
Well,
rash sort of
yeah, I'm
ish.
getting stung with like little needles at the points of the tweezers as she's pulling it out. She's going, "I'm sorry, Marky. I'm sorry." It's like that was my nickname, Marky. So anyway, that said, it never happened again. It never happened again. But I don't know what happened during those like 4 or 5 hours. Gone, totally gone. And no one. Oh, actually, on the bus, when I said, "When are we going to the pond?" Some of the kids said, "You idiot, we've been there all day." And one of the kids said, "Where were you?"
Hmm.
I couldn't answer. I think I don't know.
And
You
you have
know,
no memory of it.
none.
And do you
Yeah,
think that contributed to your seizure later on that day?
absolutely. It had a great deal to do with it. I don't know how I know that, but if you think about it, it makes sense, doesn't it?
Yes, it
Yeah.
does. Mm,
And so I was really kind of stuck about this, and I was like, kind of crazy, It was just like, wow, I don't know what to say.
very.
This goes against all the science I know now, and of course, all the science I knew then, right?
Yeah.
So, yeah. So then we have the implants. I told you that story about mine. Okay, but there's many cases, and we know about Roger Lear and his amazing research with removing implants from people and so forth.
Yeah.
Uh, very, very incredible guy. Too bad he's gone. I would have loved to have talked to him about this. I explained my experience at the doctor with the implant kind of thing.
Mhm.
But that's another scary aspect of all of this. And then we have the people that had encounters with extraterrestrial beings. Thankfully,
Mm.
I haven't had any of those experiences. But if I did, I'd be very excited about it, and I wouldn't like be scared. I would probably relish the opportunity to encounter such a
Yeah.
creature. You
I
know,
feel the same way now, but we say that now. We don't really know what we would do, right? I mean, because it could be very frightening or it could be very calming. You just don't know.
no, I know, and look at the different kinds. I mean, we have the grays, which
Yeah.
everybody
Oh
thinks we have
my.
the Flatwoods monster, right?
Run
Okay,
away.
this tall
Wow.
spade shaped head creature,
That's
little green
scary.
men, small and green. The Hopkinsville
Mhm.
goblins, okay,
Yep.
that terrorize the family in their home. The Nordics, as it says, right? They're very tall, okay, and then the reptilians, most disturbing. Now,
Yeah.
how many
Very
of these things
disturbing.
can be true? Could these all be imagination? Absolutely, they could. No doubt. Humans are wonderful with their imagination, so maybe they could. But too many people have seen grays, uh,
Mhm.
and too many people have seen other creatures like Nordics, but people from Norway that are tall and blonde. I mean, how do you know that they're not a Nordic? How do you know they're not just from Norway?
Mhm.
Okay, you don't. All right. But the reptilian, you recognize that one if you saw it. I'll tell you this, okay. Um,
Hmm.
I used to think that reptilians were just an impossibility and a silliness and what don't even go there kind of a thing. However,
However.
however, I've
Hmm.
also I really enjoy alternative history, and I've
Hmm.
gone through an alternative history um, analysis of what would have happened to the Earth had the dinosaurs not died. Now,
Ah.
intelligence isn't a foregone conclusion. It's a potential destination, not necessarily
Hmm.
the only destination. It's not at all. There's many, many branches it could have gone.
Just
Okay,
look at people on this planet.
that's right. When you have
Intelligent.
radiative adaptation, where you have one
Yeah.
common ancestor and 40 branches off of it, where only
Yeah.
one is successful, it's a rare possibility, but it's not zero. So, what if dinosaurs didn't die and the uh, dinosaur known as the Troodon, Troodon, Troodon,
Okay.
Which had the distinction of having a brain case that was growing at the time of its death from the asteroid. What if it
Hmm.
never died? Would the Troodon have been able to evolve into something intelligent? It certainly was getting more brain capacity, and that typically leads to a better capability. The Troodon may have become as smart as a dog. Maybe it would have become
Hmm.
as smart as an early hominid like Lucy. Okay. However, the Troodon was a creature that had 2 legs and 2 small forearms, kind of a thing.
Hmm.
And so, would those have developed and formed a creature that would have had intelligence? Don't know. Evolution's a fickle thing. You don't know if the intelligence quotient of a creature is defined by its journey on the evolutionary path or by the pressures put on it by the environment. The answer is it's all of those things and more. So, if we look at the Troodon's development, maybe it could have developed more, but it would have to develop the ability to create certain things that are what we consider milestones.
Yeah.
Fire, right?
Mm-hmm.
Fire is very important, um, and that's something that
Big deal.
right.
Mhm.
It's a big deal to us. So that said, you know, I don't discount reptilians because on our planet, reptiles didn't get a chance. They were wiped out 65 million years ago at the KT boundary event, which is also known as the Chicxulub impact time. Um,
Mm.
but what if that didn't happen on another planet? What if What if dinosaurs and reptiles were common?
Right.
Right. You
Humans may
know,
never have formed, right?
right. Right. Humans might never have formed, or we might be doing this talk with yellow eyes and tails at some point.
Mm.
Right. We don't know.
Yeah.
So there's a lot to it. You know, there's a variety of possibilities, and I think in the next time we get together, maybe we'll talk about the different varieties of alien life that we could expect based on the conditions that the universe affords.
Right.
You know, well, it's pretty cool, but uh, the potential for life variation in the universe is rather immense. And stellar types can tell us something. We talked about this before. These hot blue stars, all the way down to these A stars. This
Mhm.
kind of region here that you see on the screen there, or okay, right there. That this kind of region, they're too hot and too blue to really allow for life. The later A type stars down here, see the A is the temperature, down to F
Right.
and G. These guys are more conducive to life. And then you get to the K stars, they're even more conducive to life. Then you get to the M stars. These stars are the longest lived. They live trillions of years. In fact, the first M star ever formed in the universe, the first one,
Wow.
is still around.
The very first one.
The very
And
first
you
one.
can see it. That's cool.
Yes, and it's
That's
not
cool.
even the very first one is not even remotely through its lifespan because they
Hmm.
actually live trillions of years. Trillions,
Mhm.
not billions, trillions.
Yes.
Okay. Remember, a trillion is 1,000 billion, and the universe is 13.8 billion years old.
Wow.
Nowhere near 1,000, and that's just
Wow.
1 trillion. And these M stars will live trillions of years.
Very interesting.
Yeah.
Mark, you were talking, your slide prior to that was like, how could there be so many, um, of life, these different lives or whatever that you were talking about in the universe? And this isn't, you didn't ask me to do this, but that's your populated universe. You wrote that book about that and how,
Oh, that's right.
that's, if you read that, it really does explain the possibilities. And now all the exoplanets that they found and just in our galaxy alone is incredible.
Yeah, I think that's true. Um, um, that particular book, I've updated the editions, so when people order it on Amazon, they get the latest one. Um,
Awesome.
yeah,
Here we go.
that book rather, thank you. Does talk about the potential for life in the universe, and I think it's the norm, not the exception, that there's life, and that goes to my feelings that the carbon-based life, like we're made of, carbon's the fourth most abundant atom in the whole universe. Okay, fourth. Oxygen
Right.
is third. Okay, so a hefty relationship between carbon and oxygen is expected, and we see it. So that said, when we talk about these things, I think as we consider that life in the universe might be the rule, you have to say, well, justify that. I justify it through all the variations of life we have on our own planet, life that has come and gone, all based on carbon with an intimate relationship with oxygen and
Mhm.
DNA. There's
Ah,
DNA in every single life form on the planet. Okay?
right.
DNA, right?
Interesting. Yeah.
Deoxyribonucleic acid. And it's made of carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, chomps for short. Okay. And more. So you have adenine, guanine, cytosine, thymine, are the four major nucleotides in DNA. Those are amino acids that form the crux of the double helix, and we're symmetric on both sides because of the way DNA probably replicates. It
Right.
unzips a complementary side and zips up a complementary side. That's a symmetric behavior. So we are the same on left and right outside as we interact with our universe.
So
So that's
interesting.
incredible. So
And that's it.
yeah, that's right. And with that,
Wow.
I have to say, we are done for this evening, and I want to thank
Oh,
you guys for hanging out with us for the night,
yeah.
and just y'all get what you pay for.
That was so fun. So interesting, though.
Yeah, we
Love
had
the
fun, didn't
subjects.
we?
Mhm.
Yeah,
Thank
and
you.
I want to thank you, Tara, for uh, actually you kind of listened more than you contributed on. That's
That's
my
good.
fault. I
That's
just kept
interesting.
talking, but I like your
They,
questions, so thank you.
and thanks, Chanel, too.
Oh
Appreciate
yes,
her.
Chanel's done a great job.
And thank everybody for listening. And we'll see you next week, hopefully, right?
Thank you, guys. Yes, indeed. We'll see you guys. Thank you so much.